come for this. So what actually happens? It will like a lambda to lambda. There are two holes are there for in this tank. So the bigger hole you show like this. So 2 lambda. So initially what happened? The N naught is present. Now what is this? This is what A, no? And how much number? Let's say them. Okay, let it be this one. So now what happened? A tank will come here. So this will be, let it be B. This tank, let me call, this is B1, tank B2. Again, they will further undergo decay. And we'll get tank C. No hole in that. So what do you mean by lambda? Bigger hole, 2 lambda bigger hole. At t equals 0, there's a condition. And let's get into, write the equations now. Already the diagram is there. Don't go for again showing any other diagram. Already diagram is there. There's a logical thinking like this. You can put it. So at any instant of time, some water will come in tank B2, some water tank come in B1. Again B1 there's a hole. Some water from there will fill up, will form C. When it will be B1, when the number of atoms, amount of water in the tank B1 will be maximum. The rate at which it comes from this hole, the amount of water coming per second from this hole is equal to amount of water leaving per second through this hole. Then the amount of water in this tank B1 will be maximum. Logical thinking. What is Na after some time? Okay, now we'll get into this is stable. Yeah. Directly go for writing this at any time t. So for B1 will enter into B1, dNB1 by dt. dNB1 by dt, what we can write? It is the rate of formation of atoms B1. That should be equal to rate of production. What is the rate of production? L lambda Na, and rate of decay minus lambda 2 lambda Nb. NB1 you write it. When NB1 will be maximum, when these two are equal, then when NB1 will be maximum when dNB1 by dt equal to 0. So from that, what I can write is no lambda na nb1 equal 0. So nb1 is equal to how much? Na by 2. I think therefore the question asks, no? If at summation the number of atoms of B1 reaches the maximum value, the ratio of number of atoms of A to that of B1 at that instant. So shall we put the required answer? In turn, what is Na? What is Na? I think we should have a clarity. What is Na? I'll write in the diagram. What is Na? E, e to power of minus 3 lambda t. Please do notice why 3 lambda, why not lambda? What is the effective? It will undergo two processes, no? Lambda into lambda. So what is the effective decay constant? So here I'll write it like this. What is in turn lambda A, lambda plus 2 lambda, which is 3 lambda. So therefore, I think this is something very important. Do make observation. Okay, the question number 92 got over. So there's answer for 92. Next again, when the number of atoms of B2 reaches maximum, the ratio of number of atoms of A to that of B2. I think the same story. DNB2 is equal to the rate of formation of the rate of decay of A, 2 lambda Na, and the rate of decay of B, lambda NB1. And for NB2, this is NB2. For NB2 to be maximum, dNB2 by dt should be equal to 0. The ratio of number of atoms of A to that of B. So this I'll equate to 0. Should be equal to 1 by 2. Okay, this is our answer for question number 93. Okay, let's see that next part, what is there. So nothing bigger, so don't get scared. I think some of what happen if you can break up clearly things, it'll be much easier. A number of atoms of A as a function of time. I think that's what this equation, no? Once again, I'll write it here. What is lambda A? Lambda plus 2 lambda. Minus 3 lambda t. These are very popular, huh? So nothing to do. We don't have any other physics or any other mathematics much. I'll scroll down. I say this fluid mechanics method. There's a lowest level of thinking.